This lesson talks about geometric and infinite geometric series, and we're going to find the sum of the series. Now, sometimes the sum or the series has an end. So, for example, if I say the first 5 terms, add those up, or for example, in summation notation, there's a number up here. That's telling you how many terms to add up. That's called a finite geometric series. Now, when I see this dot, 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 or when I see an infinity sign, that means it's infinite. It has no end. So that's the difference between these two series. Now, each of these series has its own formula to use. So a finite geometric, we'll call this a series, not a sequence, has a formula like this. It says A1 times, in parentheses, this is r to the n power over 1 minus r. It's a little bit less clear with the pixelation here. And then when it's infinite, the infinite series would look like this, A1 divided by 1 minus r. In both cases, we need to know the first term in r, but in the finite series, we're incorporating that n. That's how many terms we're adding together. So let's see them in action. So this is a finite series because it's telling me 20 terms. That's n. I also have my first term. Now I need to find what I'm multiplying by. So here, r is 2. So all I have to do is plug in. So the sum of the first 20 terms is going to be A1, which is 2, times 1 minus r, which is also 2, to the n power, all divided by 1 minus 2. And when I plug this correctly into my calculator, I should get this really big answer as my number. If I were to write out all 20 terms and add them up, that's what I should get. We might also see a geometric series in summation notation. We're still going to use our formula, or we can actually write out all 8 terms here and add them up if we wanted to. But let's use our formula. Here, this is my n, and remember, this is r and this is a1. So now I'm just going to plug everything in. 6 times 1 minus 2 to the 8th power, all over 1 minus 2. When I plug it into my calculator, I get this as my answer. Now that's a finite geometric series because I know I have 8 terms. When it's infinite, like this example, sometimes I can find the sum and sometimes I can't. Notice this one keeps getting bigger. I'm multiplying by 5. If I try to add these up, I will get infinity as my answer. But this sequence is getting smaller, and as a matter of fact, because r is less than 1, I know it's getting smaller. And this is the case where I can actually find the sum of the series. So if r is less than 1, I can find the sum, and it looks like this. I'm going to put my first term, which is 1/2, on top, and then 1 minus r. And when I plug it into my calculator, this series, if I added up all the terms all the way to infinity, they would add up to 1. This one's also an infinite series because it has infinity at the top, and I need to make sure that this number right here is less than 1. Okay, it has to be less than 1. And since that's the case, all I have to do is plug in the first term, well that's 5, all over 1 minus r, which is 1/2. And when I do that, I'm going to find that my answer is 10. So if I were to write out all the terms from all the way starting with 5 as my first term all the way to infinity, they would all add up to 10. Pretty amazing.
Made with Doodlecast Pro.